G'day all and welcome to another C++ tutorial. So we're going to start talking about user-defined data types here, and I think we just program a little game so that we can see what we're doing. It's always best to have some sort of visual representation of what's happening, so yeah, we might just make a little maze game. This tut is going to be on structures, which is really the very beginning of object-oriented programming. So structures themselves aren't actually object-oriented programming, but they do share a lot with classes and objects, and they're a good place to start. So basically, we get to define our own data types. We're not stuck with using integers or floats, we get to define our own. And one way that we can do that is with the structure, or struct. So to define a new structure, the first thing you've got to do is have a definition. So struct is the keyword, and then map tile is the name of the new structure that I'm inventing. Then we open and close curly brackets, and inside these curly brackets we put different elements, the fundamental data types, or indeed other structures, and each thing that we put inside these curly brackets, every single map tile will have one of them. So let's just see what that means. If we go char and tile character, settle down, semicolon, bool, walkable. Okay, so I've just made my own data type. It's called map tile, and every single map tile has two items. It's got a character, which it calls tile character, and it's also got a boolean variable, which is called walkable. Every map tile that I make has these two things. So tile character I'm going to use to print out some value so that we can see if the map has walls or floors, and walkable I'm going to use to decide if the player can walk over the particular tile or not. So obviously the player can't walk through a wall, and we're going to want to know that. Okay, so what have I done here? I've defined my own data type called map tile, and after I've defined that data type I can then use it and actually create an instance of map tile. So this is I guess the definition of a map tile, and this top bit here is just the declaration of what map tiles are like. So we could say something like map tile M, just like that. That's actually going to create a new map tile, and it's going to call it M, and this particular one will be global since it's not defined inside any function. But M just here has two items. It's got a tile character and walkable, which is a bool. And if we want to set or read one of these two items, we use a special syntax with the period. So m.tilecharacter equals something like that. This period just here means the tile character belonging to M, or M's tile character. Or we could say something like maybe map tile Johnson, something like that, and we could say Johnson.walkable equals false. And the important thing to note is that the walkable just here, or Johnson's.walkable, is a completely different value. It's a completely different bool to this one, M.walkable equals false. M has its own walkable value, and so does Johnson. They're two different map tile objects. And the cool thing is that once you've actually defined your own variable type, you can make an array of it. Just like that. And here we start to see all this stuff come together. So a 2D array, 10 by 10 is my map tile. Actually, what I might do is go int const map width equals 10, int const map height equals 10, and we say down here map width and map height. Okay, yeah, if I make those constants, then I can easily change these values later on. So int const is a modifier, and that just means that map width is an integer, but it's constant. I can't change it. If I was down here in main and I said something like map width equals 25, C++ is going to complain. It won't let me change it. But saying something like map tile map and then using those two values in my dimensions means that later on, if I choose that I want a bigger map, I can do something like that, and it's just going to make a bigger map. Anyway, that's not important. What's important is that we've made a 2D array of map tiles, and yeah, each tile in there, every one of those 100 map tiles, which I've called map, has its very own tile character and its very own walkable. So what we can do then is void something like this, oops, generate map, and in here we can randomize the timer. Okay, so we've not really been through it, but to generate random numbers on a computer, you know, they can't actually generate random numbers, so you've got to generate these pseudo-random numbers, or quasi-random numbers. Computers can generate things that look random, but in reality they're not. And we do that by, first of all, setting a seed, and that's what srand time null does. Time null is actually going to read the BIOS clock on your motherboard and get a long integer from that. I think it's a long integer. Let's have a look. Oh, it's a time_t object, which I believe will just be a long integer if you follow the declarations backwards through the headers. But basically, every time you run your program, the value that time has will be slightly different. So srand is actually going to set a different seed each time we run our program. But for int y equals 0, while y is less than map height y plus plus, point x equals, what does it equal? 0, while x is less than map width. Okay, so we're going to generate our map, set up our map, and we went through this in a 2D arrays tutorial. Yeah, to step through a 2D array, you usually nest for loops. So something like that is pretty much what we want to do. And we int t equals rand %2. Okay, so another integer I'm declaring in the middle of these two nested for loops, and to actually generate a random number, once we've set the random seed with srand or seed rand, to generate a random number we call this rand function, and that takes no arguments, so the open and closed brackets are blank here, but that actually returns a random value from 0 to max int. Not a random value, really, it's a pseudo-random number like we just said, but it'll seem random. So it's going to pick a number, say 13 or 29 or 528. And if we divide that by 2 and get the remainder, remembering that the percent symbol here is modulus, or the remainder, if that's an even number, we're going to get 0 back in t. If the random number that it selects with rand here is an odd number, we're actually going to get 1 in t. So we've basically got either 1 or 0, and they're random numbers. So we can use that if t equals 0, map x y dot tile character equals a wall. Okay, so if the particular map tile that we're looking at, we're stepping through the 2D grid just here with these two nested for loops. If the particular map tile that we're looking at, if we generate a 0 with this rand call here, then we'll set that to a wall. Otherwise, else. So this is what's going to happen if rand happens to generate an odd number. We want to do almost the same thing, so I'll just copy it and paste it down here. But this time we want to generate a floor, so yeah, something like that. So the player can walk on a floor, they can't walk on a wall, and I've set walkable to false and true, just like that. Okay, the other thing that we might want to do is set walls along the outside. Actually, no, I won't be bothered. I'll tell you what I will do though is map 0 0 dot tile character equals a floor. I'll just make sure that the top left corner is a floor, because that's where we're going to put our player, and it would look pretty silly if our player started on a wall. Okay, so if we come down here, generate map, we call that function to generate the map, and once the computer's actually run this generate map function, it should fill up our map array just here, our 2D grid, with these floors and tiles. What we're going to want to do is print it out to see what it looks like. Print map. Void. Once again, to print out the map, we need nested for loops for y equals 0, while y is less than map height. And the other one I might just copy from here because I'm lazy. Okay, cout map x y dot tile character. And after each row is printed, with this inner for loop just here, and whenever y increments, we actually want to put an end L, an end line, so that we get a nice box printout of our map. Let's just see how that goes. I'm going to put a getch down the bottom. So there's no getch in Linux. If you're using Linux, you'll have to use something else. But I'll just use getch so that the screen doesn't close. Instead of setting a breakpoint. It just means get character, basically. Wait for someone to hit, enter on the keyboard. Okay, so there's our map, ladies and gentlemen. That's pretty cool. A bunch of floors and walls. What we want to do now is put down a player. So there's no good having a map without a player. Let's say there's another struct, and this one's called point or position. Probably doesn't matter. Int x and int y, and we'll say player pos. You can declare an instance of your structure straight after you've closed those curly brackets, just like this. So player pos just here is an instance of point. So player pos.x can be something, and player pos.y can be some other integer. Point is just another structure. So this particular structure, point, is just a 2D vector, basically. It's got x and y. Not a vector in the standard template library sense. Just a... yeah. Okay, that's pretty cool. Let's start our player. If we scroll back down to main, let's start our player. We go player pos.x equals 0 and player pos.y equals 0. We'll start our player at 0, 0, so that was the top left-hand corner of the map. And when we're printing out the map, we also want to say if x equals player pos.x and y equals player pos.y, I might say an at symbol. Okay, so the player is going to be drawn as an at symbol. All I've done here is said that when we're printing out the map, if we happen to be at the square where the player is, instead of printing the map tile, we want to print the player's character. Just like that. So if we hit run again, we should see the player up in the top left corner. There it is. Okay, the player's a little at symbol. And the next thing that we want to do is make it so that the player can move around. So I'm just going to choose 4 keys, N, S, E, and W, for north, south, east, and west. And we'll make it so that the player can move around, but so that they can't move through walls and they can't move off the map. Let's have a go at how we would do that. Okay, basically, while true, I won't use getch, I'll use cin, just in case, cin option. Let's see out here, N, S, E, or that, or Q for quit. Okay, so we just print out a little menu, north, south, east, or west, or Q for quit. Those are the options that the user has, and I might just char option equals maybe N or something, it doesn't really matter. But once we've gotten an option from the user, we go if option equals N. Okay, so the user has just typed N for north, and we know that the player at the moment starts in the upper left-hand corner of the screen, so they can't go north. North is up in computer games, so they can't go north. What we want to do here is say and player pos.y does not equal 0. Actually, you know what? I might not do it like that. I might not do it like that at all. What we might do is say and map player pos.x player pos.y. Whoops. Yeah, no, we'd better do it like that actually. And yeah, sorry about that, confusing myself. So basically all I've said here is if the player has just typed N, so they want to walk north, and their Y value is something other than the very top, and also where they're trying to walk isn't a wall. So if it's walkable, and they're not on the very top, and they've just typed N, then player pos.y minus. Move the player up. If I just copy that and do much the same thing for south, S, which is moving down the screen, what we want to do is if option double equals S, so the user has just typed S to move south, and player pos.y is less than map height -1, so they're not on the bottom row. You know, we've got to check if they're trying to run off the bottom of the map. And the other thing is that it's this one. Okay, so map player pos.x player pos.y +1 is the square that they're trying to walk to. And same with up here. This one, player pos.x player pos.y -1. That's the square that they're trying to walk to if they hit north. Anyway, if they've hit south and all that goes well, then we'll actually move them south. So, yeah, that's pretty good. And the next one that we might do is E for east. So this time, instead of checking for player pos.y being less than or greater than the map's height, we're actually checking if player pos.x is greater than 0. So we're trying to make sure here when they're... Oh, wait a minute, no. If... Yeah, when they hit east, they're walking right. Yeah, right across the screen. So we've got to make sure that they're not on the very right-hand edge. And if they're on the very right-hand edge, then we obviously can't walk them that way. They've hit the edge of the map. And instead of checking that square, the square that we're checking is that one. What's the problem? Expression must have a pointer to... What? I don't know, that's stupid. Anyway, it's not gonna... Oh, here we go. Ah, that's better. Okay, so if the users hit east, and they're not on the very right-hand side of the screen, and the square that they're trying to walk to is a floor, or it's walkable, then we'll move them east, which is x++. So player pos.x++. And the final one that we want to do is if they've hit W for west, and if they're not on the very left-hand side of the screen this time, and the square that they're walking to will be player pos x -1, if that's walkable, or if that's a floor, then the x value minus. And finally, if option equals Q, yeah, don't forget that we've got to break out of this infinite loop that I put at the top here while true. Okay, so that should pretty much do it. Look, all I've done is read something from the keyboard, N, S, E or W, capital letters too, be careful if you're typing this out and playing it yourself. They're capital letters. You can make them lowercase as well if you want. But then I've made sure that they're not along the edge of the screen. I've made sure that they're not trying to walk outside of the screen. That's this player pos dot, y is greater than 0 and all of this business. And the final thing that I've done is checked that the map tile that they're moving to is walkable. And I think, or I hope you can see how useful structures are. Anyway, let's give it a play and see what happens. This is going to be cool. Alright, yeah, there's my player up in the corner. Okay, so let's type south. There he is. I'm pointing, but you can't see. I'm pointing to him there. Okay, we'll type south again. Yeah, so he can't walk through walls, which is good. We'll type east, south, N. Okay, so that's a pretty boring map. I might just quit, and if we run it again, we should see a completely different map. Oh, we do, but look at that. He's stuck in the middle of nowhere. Oh, I can't get out. Minecraft deserted island level. Ah, this is a bit better. Yeah, so we're moving the little @ symbol just there. Yeah, that's what we're doing. Yeah, so anyway, that's about all that I wanted to say. What I was really trying to introduce you to, and I know it was a lot of coding and probably a pretty long tutorial, but I really wanted to introduce you to structures. So this is them here, really. Yeah, you just declare them first with struct and then give them a name and say what fundamental data types they're made up of. And then later on, you can actually use those as if they were a perfectly normal C++ data type. It's incredibly powerful. Yeah, I hope you can see how useful that is. Let's try and make a bigger map. 20. This will be cool. Oh, there we go. Bigger map. Oh, it's gone off the end. Ah, these are all bad. Let me just get rid of some of these wall tiles. Oh, there's only one wall now. Yeah, well, that's better. Now I can walk around and not bump into things all the time. Yeah, anyway, it's a pretty good game. I hope that's a useful introduction to structures, and I guess I'll see you later. Thank you for listening.